afternoon, everyone. My name is Chen Shay. I'm a software engineer on the AMP project. And today, I'm going to share with you our secrets for making web pages fast. And hopefully, you'll learn some of the best practices and apply them in your own development process. But first, let me show you what problem we're trying to solve. This is a typical mobile page. And I, as a user, want to see this page. I have just clicked on a link to open this page and read the contents. But I can't, because there are things that are preventing me from doing so. The first is that it's extremely slow to load. In fact, does anyone here in the audience know how long it takes the average mobile page to load? 15 seconds? 15 seconds. You know that after 3 seconds, half your users are gone. After 10 seconds, nobody's there. 15 seconds is horrible. The average is 19 seconds. So after I finally loaded my page, I have this flash of unstyled content, which is very jarring and could possibly give you epilepsy. And after it takes forever to load, I have a flash of unstyled content. I start reading the page, and 20 seconds later, when I'm just at the best part and I want to see what happens, this ad loads out of nowhere and shifts my content around, and I lose my place, and I don't know where I am anymore, and I really want to know what happens next. So then I try to look for where I was, but now my browser is kind of frozen or it's janky, and I can't find where I left off. This is a horrible, horrible experience. We have all been here before. But why should you, as developers, care about this? You have a million things you could be doing with your time. Why is it important to fix these issues? Well, my answer is that it's important if you want to keep your users and your revenue. Today, I'm going to take you under the hood and show you what's going on that's causing all these issues. I'm going to show you the 10 steps that we take with AMP to address these issues to make the web experience much better. And hopefully, you'll be able to apply what we do in your own development process to make your pages better and faster. So first, let's look at the first problem, which is that it's very slow to load. And what's happening here is that there are things that are blocking the render. And these things happen to be files that you have to download before you could see anything on your page. They could be CSS files, they could be JavaScript files, and they have to download, and it takes a really long time. And to solve this, we decided that we need all scripts to be asynchronous so that you can see the HTML on your page, you can have the page load, and the scripts will load in the background, and they don't have to block the render of your page. The next thing is that we only want to download JavaScript that you need on your page. So here, for example, is a carousel. Not every page will have a carousel. So not every page should download the JavaScript of a carousel. So we break the page up into components, and we tell the browser specifically what JavaScript we want to download so that you only download what you need for your page. The next thing is that we inline CSS. So external style sheets tend to be very large, and they take a very long time to load. So inlining it means that you don't have to download them separately, and it's going to be a lot faster. This is like taking a carry-on luggage with you when you fly. It's going to be a lot faster than if you check in your baggage and end up being one of these people waiting at the carousel. Nobody wants to be here because it takes forever. So don't check in your luggage, carry it on with you, inline your CSS. Now, when you fly and you take a carry-on suitcase with you, you have to limit how many things you bring, right? Because you don't have room for your entire house in your carry-on luggage. And we decided that we're going to limit CSS by 50 kilobytes. And 50 kilobytes is just like the space in your carry-on luggage. It's just enough for all the things that you need, but you're not going to bring a bunch of junk that you don't need. The next thing, so also the 50 kilobytes, what it forces you to do is clean up CSS that you don't longer need. Now, around winter time, a lot of us have these promotions for Christmas or for the holidays, for certain sales. And we have CSS for it. And then we get rid of the, we don't show it anymore because, in January, Christmas is over. But someone forgot to clean up the CSS. It's still there, even if your users don't see it. But they're paying for it with their time, because it takes longer to download, and their wallets, because this takes up data. So limiting CSS to 50 kilobytes means that you're going to have to clean up these things, and it's going to give your users a much better experience. The next thing I want to talk about is third-party JavaScript, and mainly in relation to ads. So ads have not all kept up with the times, and a lot of them think that they need third-party JavaScript for their executions. And because ads are important and they make money, we have to allow them to exist. And so they use third-party JavaScript, but we have to tell them they need to be in sandbox iframes, because third-party JavaScript does horrible things. First, they write sync scripts. So again, you have this issue where you have to wait for these scripts to load before you could see anything on your page. The next thing is that they document.write more sync scripts. So you have a lot more sync scripts that you have to wait for, and it all adds up. And the third thing that they do is style recalculations, which is very heavy on the CPU, because they have to scan your entire page. And it also might be wrong, because if you name a CSS class the same thing, an ad could potentially change the style of something on your page, such as your logo. And you don't want that. So by limiting third parties to these sandbox iframes, they're still going to do these bad things, but they're not going to affect the rest of the page. They're not going to affect the load. And they have their little box where they can play. And also doing style recalculations it's going to be a lot cheaper, because it's only going to scan the contents of the iframe rather than your entire page. This is like allowing your toddlers to play with paint. You know that they're going to make a mess. You just want to keep that mess away from other parts of your house. The next thing we do is resource prioritization. So a typical mobile page is a lot longer than your viewport, than your first viewport of a phone. And sometimes we don't actually download the entire page when a user taps on it. But the user perceives the load to be instantaneous because we load the contents in the first viewport before we load the rest of the page. And this makes the perception of the load instantaneously, even if we didn't have the time to download everything. And we also do something called Preconnect. So for example, here's a YouTube video. And to load the contents of a YouTube video, there are a lot of things going on. But one of them is we have to connect to the source, right? We have to connect to YouTube. And that takes up time. So by connecting ahead of time, if we know that there's a YouTube video or an image, or for example with Twitter, to load the content, you have to connect to one server. To load images, you have to connect to another server. By doing these connections ahead of time, when it comes time to load the contents, it's going to load much faster. So now we've gotten rid of this slow loading problem. But we're not done, because we have this flash of unstyled content, and we don't want this. And what's happening here is that the page is loading, but then the styles are being applied after the page has loaded. And to solve this problem, we use an invisibility trick. And we set the opacity of the body to 0. So it exists, but it's invisible to the user. And then the styles are applied. And eventually, the JavaScript will load and unhide the page. So to the user, it's perceived as being loaded like this first. But what happens if there's no JavaScript? Well, we have this no script to unhide the body if there's nothing there to unhide the body. And then finally, what if JavaScript servers go down, which can happen every once in a couple of years, right? And to address this issue, we do a CSS timeout, animation timeout. So if for some reason the page thinks that there's a JavaScript, but the server times out, then we will have a timeout that will unhide the body if the JavaScript never arrives. Now, what I just described to you, it's what we currently do, but there is a bit of a time delay, and we're currently working on doing server-side rendering so that there will be 0 time delay. So now we load fast, we got rid of the flash of unstyled content, but we're not done because 20 seconds into reading, this ad loads out of nowhere and shifts the content all around, and nobody likes it. And what's happening here is, just like I talked about earlier, that ads use these third parties, JavaScript, and they're really slow. They take forever to load. We can't force all the ads to be implemented in a way that they're going to load fast, right? We can't force them to do that. But we have to allow them to play. So to solve this problem where we let them exist but don't punish our users, we put these placeholders because we know that there's going to be an ad. And we have static resource sizing, so we know the size of the ad. And so the user can read the contents of the page, and then it's up to the ad to load on time. And eventually, the ad will load, and it won't shift the content. So the user can continue reading and have a pleasant experience. And we've solved this content shifting issue. But we're still not done, because we need to address this frozen Janky problem that's happening. And what's going on here is that the CPU is overworked and overloaded. And to address this, we do a few things. First is that style recalculations are really expensive. So we want to minimize style recalculations. And we do so by caching the coordinates, so we know where all the things are. And then we know when things resize, and that's the only time that we're going to recalculate the style. Also, we batch the DOM access. So for example, I have this code sample where we measure something, and then we set the height. We change the DOM. And then we measure something again, and then we change the DOM by setting the width. And then we measure something again. And this is a very reasonable chunk of code. But what's happening here is that the style is being recalculated every time you measure something because the DOM has changed. So by batching the DOM access, we can schedule a read for the first animation frame, and then we can schedule a write for the next animation frame, so that you only recalculate the style one time in this example. And this is going to be a lot less expensive for the CPU. So we have a max of 1 style recalculation per frame. And this is the main thing that makes AMP pages fast when you interact with them. This is really the only thing you can afford if you want to get to 60 frames per second. And we only do 2 style recalculations for a page load, which is very low compared to other pages. The next thing is that we want to do GPU optimizable animations only in our AMP components. So animations are very expensive for the CPU. And we want the CPU to hand over the work, to delegate the work over to the GPU, because the GPU can do animations really quickly and really cheaply. And so in our AMP components, we only allow animations that the GPU can perform. In this case, it's transform and opacity. So if you wanted to animate the width, the GPU is not going to know how to do it, and it's going to say, CPU, you go ahead and do this. So we don't allow width or height animations, but we do allow transform and opacity because the GPU knows how to do this, and it can do it very cheaply. So now we've gotten rid of the frozenness and jankiness, but I want to take a moment. So everything I talked about now, any developer can do. You can apply in all of your development processes. But because we're talking about AMP, AMP also uses a cache. So if you wanted to build a system, it's a little bit more complicated, but you can optimize with cache. And what we do is, first of all, the cache, we have servers that are located in lots of places all over the world. So they're physically located next to you. And that means that delivery of the content is going to be a lot faster when these servers are located next to you. And these servers, they could be Google servers or they could be Cloudflare servers. It doesn't matter. But that's going to give you that real boost of speed, is to have this cache. And some of the optimizations that we do on the cache is, the first is efficient pre-rendering. So browsers used to have this thing called rel equals pre-render, where you could tell the browser, you could have a link on your page, and you could tell the browser, hey, download, pre-render this link. So the browser would download all the contents of the page, and then when the user would click on the link, the page would load instantaneously. But the problem with this was that it downloads the entire contents of the page, all of the images, all of the ads, all of the analytics, the third-party JavaScript, and it would execute arbitrary JavaScript in the background, and that's very heavy for the CPU. So instead, what we did is we pre-render only the first viewport. And we don't execute any third-party JavaScript, so none of the analytics and all that stuff. And what this does is it makes pre-rendering extremely cheap and non-expensive. The next thing we do is resource compression. And by resource, I mean all the things, all the files that the users are going to download onto their page. And some of these files are JavaScript files. And so we use a Clojure compiler to compress our code. And here's a chunk of code on the left. And if you run it through the Clojure compiler, it's going to compress it to the chunk on the right. And on top of that, it also does tree shaking. So it gets rid of dead code and methods that aren't being used and so on. And we have our own optimizations that we do on top of the Clojure compiler. So we get rid of developer code, such as logs, that you only use for development. But your users, they shouldn't have to download those logs, because they're not going to be useful. So we get rid of those as well. On our main page, so on the HTML, we use a compression algorithm called Brotli. And that saved us 8% over gzip, which is another compression algorithm. And then finally, I want to talk about images, because images make up 64% of the bytes of an average mobile page. That's huge. So if you can affect images, you can have a huge impact on the size of the page. So we compress images. The first thing that we do is we remove invisible data. This is metadata that your users don't see, such as geolocation and so on. And we also we reduce the quality of the image, and we try to have one color sample for every 4 pixels. And this reduced the image size by 40 bytes. On top of that, for browsers that support WebP, which is another image format such as JPEG, we convert the images to WebP, and that reduces the images further. And then for Chrome users that have data saver enabled, or places in the world where data is extremely slow, we lower the quality of the images even further to save more bytes. So now, when we apply these 3 things on an image, let's look at the before and after. So before, we have 240,000 bytes for the left image, and the right image has 25,000 bytes. That's about a 90% reduction in bytes. And keep in mind, images make up 65% of your page. So that's pretty big. And you might look at it and say, you know what, I don't like the image on the right. It's not as good. I could tell the difference. But I want to tell you that actually, I switched them. So the image on the right is the before. The image on the left is actually the after. So now, to summarize everything, if you haven't paid attention or if you just walked in, to make web pages faster, we want to unblock the render by making sure that scripts are asynchronous so you don't have to wait for them. You want to bring your CSS with you. You want to inline it, and you want to limit it to 50 kilobytes. And third-party JavaScript is OK, but you want to put them in iframes so they don't affect the rest of your page. And you want to prioritize your resources. You want to load the things that the user is going to see first. Also, we use opacity magic to make sure that this doesn't happen, and we're going to do server-side rendering in the future so that there isn't even a tiny bit of a delay. And you want to stop shifting by having placeholders and static resource sizing so that your users don't suffer from this atrocity that ads usually commit. And then you want to unfreeze your page by giving your CPU space to breathe. So less style recalculations, and let the GPU do the animations. And then if you can do cache optimizations, then do cheap pre-rendering and compress your page. So let's see how we're doing. 19 seconds for the average mobile page to load, and less than 1 second for AMP on search. And what does this mean? Well, it translates to 10x less data. We have higher CTR. Publishers are seeing higher CTR and higher ad viewability. And today, there are about 2 billion AMP documents from about 900,000 different domains. So hopefully, if you apply some of these things, you can see similar benefits as well. And if you don't want to do all of that work, you're welcome to use AMP. Now, I know this is JSConf, and you all love JavaScript, so you might not want to use AMP because it doesn't involve writing a lot of JavaScript. So I'm here to tell you that you're welcome to write progressive web apps and use AMP for content delivery, and that way you can write lots of fancy JavaScript. And if you're passionate about what we do and you want to help out, AMP is an open source project, and we welcome contributors. So you're welcome to work on the project with us and create AMP components. To learn more about the AMP project, please go to ampproject.org, visit our YouTube page. If you want to contribute, bit.ly/helpamp. And right after this, we will be at the AMP booth if you'd like to meet our team. Thank you.